The last part of the section that I was going to start up on this Friday, that we are not going to have class, is trigonometric equations. So this is what I was going to finish with. Trigonometric equations is we're going to solve for a value. We're going to find the value of an angle for which, two sides of an equation hold. So for example, we're going to start solving this equation using everything that we already know. The first question, you need to find all of the solutions of a trigonometric equation. What does it mean? Remember that the value of sine repeats every 360 degrees. So you need to find and give, once you find the general solutions, you need to give an expression that will represent all of the angles. Like if you do several rotations, that will give you the same solution, okay? By adding a multiple of 360. That's exactly what it is. So first of all, let's treat this sine as if it was a variable, and what you have to do is put the signs on the same side, like if it was a variable, and everything else to the other side. So I need to bring the 5 sine of x over to the other side by subtracting it. So you get 3 sine of x minus 5 sine of x is negative 2 sine of x. Then bring down the minus 2 equals to negative 1. Then move the 2 over to the other side. So we get negative 2 sine of x equals to negative 1 plus 2 is positive 1. Then you divide both sides by negative 2. And you get that sine of x is going to be equal to negative 1/2. Then, if you want to get rid of the sine, remember that you have to do the sine inverse, right? So x is going to be equal to the sine inverse of negative 1/2. By doing the sine inverse, remember, means with it, what does the inverse mean? That you're finding an angle for which the sine is going to give you a value of negative 1/2. That's basically what you need to look for. Find an angle for which sine gives you an answer of negative 1/2. So, first of all, how do we find that value? We need to determine, okay, if I look at the 4 quadrants, first of all, the sine is negative. We need to determine what quadrants will make sine to have a negative value. That is the first thing. So for negative, if you remember, sine is going to be negative either in quadrant 3 or in quadrant 4. Okay? So that means that we're going to have 2 triangles. Okay? We need to find that angle. This is going to be an angle, right? So we need to find that angle theta either in quadrant 3 or in quadrant 4, for which the value of the sine is going to be negative 1/2. What is sine? Y divided by the radius, right? Y is 1 and the radius is 2. Y also here is 1, the radius is 2. And it is a negative 1, right? Because it goes down. So, and that's exactly what we see right here, negative 1/2. So now we need to determine what angle of reference will make that happen. Okay? So the opposite of what kind of angle will have an opposite side of negative 1 and a hypotenuse of 2. The other one is radical 3, so this one has to be a 30-degree angle, right? Also a 30-degree angle right here. So give me an angle like in standard position. What will be the angle in standard position that will give me that angle of 30 degrees of reference in this quadrant 3? So you know this is 180, right? 180, and then if I have 30 more right here, that angle will be 210 degrees, right? So one of my solutions for x, I'm going to be writing my solutions down here. So x is going to be equal to 210 degrees. That is one general solution, right? But now I want you to do the following. Now if you extend it all the way to the other angle, because now the other angle is all the way over here, So what is the angle of reference, not the angle of reference, but the angle in standard position that will start from here, from 0, all the way to the terminal side right here where the 30-degree angle is? That will be, basically the whole rotation is 360, so 360 minus 30 is 330 degrees, right? So that means that the other solution for this will be x is equal to 330 degrees. Those are the solutions that will give you negative 1/2 for the sine inverse. That will give you that value of negative 1/2. Okay, 210, which is a 30-degree angle in quadrant 3, and 330, which is a 30-degree angle in quadrant 4. So, but now we need to find all the general solutions, not only these two. Remember that sine is going to repeat that value of negative 1/2 is going to again repeat after another 360 degrees, after another 360 degrees, and so on. So that means that the general solution for this equation would be that the answer will be x equals to 210 degrees plus a multiple of 360, which is going to say 360k, where k is any integer. Like, for example, when k is 0, then you get 210. When k is 1, then you get 210 plus 360. When k is 2, then you get 210 plus 360 times 2, which is 720, and so on, and so on, and so on. Those are going to be repetitions of the same angle, but with different rotations, with more rotations, right? Same thing with this one. This is going to be a 330, and it's going to repeat every 360, every multiple of 360. So these are going to be my solutions where k is any integer. Okay? If you have any question in class, just let me know. Alrighty. So I'm going to give you some examples of the solutions that will give you negative 1/2. For example, some solutions could be for 210. It could be 210 degrees. That will give you a 30-degree angle in quadrant 3. If I add 360 plus 210, 570. If you do one complete rotation of 360 and then 210 more, then that 570 is going to be exactly the same as this angle in quadrant 3, a reference angle of 30 in quadrant 3. Now another one, if you add another 360 and so on and so on and so on, it keeps on going, it keeps on repeating. Now for 330 is the same thing. Some of the solutions are 330 degrees. Then if I add a multiple of 360, 360 plus 330, 690, right? And then another plus another 360, it keeps repeating, so it's going to give you the same angle, but with after one rotation, after another rotation, and after another rotation, and so on and so on and so on. Okay? Alright, now we're going to be more specific for the following questions. I'm going to be more specific. I'm going to ask you, give me all of the solutions, let's say for example between 0 and 360, or give me all of the solutions between 0 and 540, or between 0 and 720. Okay, so I'm going to be more specific. Let's start up with this one. On this equation we want to find the angle for which tangent of 3x is equal to 1, but anywhere only the angles or the solutions between 0 degrees, this is 0 radians means 0 degrees, and 2 pi means 360 degrees. Just any angle between 0 and 360. Keeping in mind that tangent is not, remember that tangent is going to be periodic every 180, so it is not every 360. Every 180 degrees is going to repeat over and over and over and over again. Okay, so let's find the solutions for this one. So it is ready, it is set up for you. All I have to do is get rid of the tangent by doing the tangent inverse. Remember, on both sides, doing the tangent inverse. Okay, so that is going to cancel out the tangent. So you're going to get that 3x equals the tangent inverse of 1. So first we're going to start with the 3x, then we're going to solve for x. But first, let's find what is the angle that will give me a value of 1 in tangent, and on which quadrants will the same angle be repeated. Okay, so first of all, that value is a positive value, right? So we need to determine on which quadrant is tangent positive. Tangent is positive either in quadrant 1 or in quadrant 3. So we are going to create the triangle right here, starting with quadrant 1, and we need to remember that that is going to represent an angle, theta, some angle theta that we don't know what it is, and also in quadrant 3. But wait a minute, didn't we say that tangent is going to repeat every 180? That is basically 180 after. So we don't actually need to provide both answers in this one. Because if I just provide the first answer, when I add a multiple of 180, it's going to give me the other one, plus another 180, gives me this one back, plus another 180, gives me this one again, and so on, and so on, and so on. So for tangent, in this case, it is not really necessary to provide both of them. Because by adding the 180, I'm going to get the next one on the quadrant 3, plus 180, I get the one in quadrant 1, and so on, and so on, and so on. So let's just find the first one. Tangent has a value of y over x, right? But in this case, that one is just a 1, which means 1 over 1. So your y is 1, and your x is 1, right? So 1 over 1, that is my y and my x, and that is the square root of 2. So what is that angle? It's a 45-degree angle. Okay? And we already know, so the answer for this is going to be that 3x equals to a 45-degree angle, right? But then, after how many degrees is it going to repeat again? A multiple of 180, right? If I add 180, it repeats the value, right? It's going to be again 1. And if I add another 180, it repeats again, right? If I add another 180, it repeats again, and so on, and so on, and so on, right? So that's what. How do we write those repetitions? Plus 180 degrees k, where k is any integer. Okay, but those are the solutions for 3x. How do I find the solution for x? Very simple. Divide both sides of this equation by 3. Everything divided by 3. And that is going to give you what you need. So x is equal to 45 divided by 3 is 15 degrees. Plus 180 degrees divided by 3 is 60 degrees k. And again, where k is any integer. Are we done? No, because that's not exactly what we're asked. We don't. This is the general solution, but we're not asking for the general solution. We're asking for all the solutions between 0 degrees and 360 degrees. So how do you find all of those solutions? Well, give me some values of k. For example, when k is equal to 0, what is the first solution? 15 plus 60 times 0 is going to give you 15 degrees. This is my first solution, right? And it is still less than 360. So as long as it gives you an angle less than 360, we are still under the solutions. X is equal to 15 plus 60 times 1 is going to be 75 degrees. We're still in the solution, right? Between 0 and 360. Now when k is equal to 2, then you get x is equal to 15 plus 60 times 2. That's 120 plus 15 is 135. That will be the next solution. Okay. Then let's go to the next one. So we're still in the range, right? So when k is equal to 3, we get x is equal to 15 plus 60 times 3. 60 times 3 is 180. 180 plus 15, 195. Right? And that's the next one. Then we keep on going. When k is equal to 4, what is x? 15 plus 60 times 4. 60 times 4 is 240, right? 240 plus 15 is 255. and we are still in the interval of 0 to 360. So we keep on going to the next solution. When k is equal to 5, x is equal to 15 plus 60 times 5. 60 times 5 is 300. 300 plus 15 is 315, and that will be the next value. Okay? And then let's find the next one and see if it is still in the range. When k is equal to 6, x is equal to 15 plus 60 times 6, that's 300, and 60 times 6 is 360, right? 360 plus 15, 375. So this one goes over. So this is no longer a solution in the range that we wanted. So all my solutions for x in this equation would be 15 degrees, 75 degrees, 135 degrees, 195 degrees, 255 degrees, and 315 degrees. All of these solutions will give you the value that whenever you have 3 times the tangent of 3x is going to equal to 1. And we can check it, so you can verify, okay? If you want to check your solutions, you can do that. For example, look at the first one. Tangent of 3x, which is 15. Is it equals to 1? That gives you tangent of 45, right? Is tangent of 45 equals to 1? Yeah, right? Then we can do the same thing for the next one. We can keep trying. So what if I do tangent of 3 times x, which is 75 in this case? Is it equal to 1? Let's check. Tangent of 3 times 75 is how much? 225. Isn't that a 45-degree angle in the third quadrant? Yes, right? So it's going to give me a 45-degree angle, which is going to give me -1 divided by -1, which is still equals to 1. So that one checks also, right? If you keep checking all the other angles, all of them will give you an answer of 1. Okay? You have any questions on this problem? Just let me know. You can keep checking them by doing tangent of 3 times 135, so which is still in all of the cases is going to be true. Tangent of 3 times 135, does it equals to 1? Tangent of 3 times 135 is going to be tangent of is it what? 4 or 5? Yeah, right? 4 or 5? Is that equals to 1? 4 or 5, if you do one complete lap of 360 and then plus 45 more, that gives you 4 or 5, right? Which is going to be a 45 angle in quadrant 1. And if you do the tangent, it will be y over x, which is 1 over 1, and that is still equal to 1. Okay? If you have any questions, again, just let me know. Next question. We're going to do a few more because with the class time, I was probably just going to do all the way to number 3 or number 4, depending on the time. So this Friday. So I'm going to just go ahead and give you all the way to number 3 and stop. 3 or 4, so just in case. So on this one, let's solve for this equation right here. Sine of x divided by 2 equals to the square root of 3 over 2. So the first thing is that we need to get rid of the sine. So to get rid of the sine again, we have to do sine inverse. And when we do the sine inverse, remember we're talking about an angle, right? So this right here represents some angle theta. We need to find that angle theta. So right now we're going to find the solutions of x divided by 2. Then we go into the solutions for just x. Okay, so let's begin with x divided by 2. Now, this is a positive expression. Remember, that is the first thing you need to check. So we need to determine in the first place in which quadrants is sine positive. Sine is positive in quadrants 1 and quadrant 2. So we're going to draw a triangle, and looking at the values, we're going to see what the angle is going to be. So this is my angle of theta. So right here, this answers is not like the tangent. Right here on this one, the answers will be different, because if you remember, for For tangent, it was periodic every 180. So we could get the next angle with tangent for positive or negative, because it's quadrant 1 and quadrant 3 is positive, quadrant 2 and quadrant 4 is negative, so it's 180, 180, 180 to get from one to the other one. Right here, sine is periodic every 360. So these two angles in quadrant 1 and quadrant 2, every 360 will generate a different angle. So we have to give both separate solutions, because if I add 360 to this first angle, it's never going to land in this angle in quadrant 2, right? So those are two separate angles in this one. So for sine, remember that the value for sine is y divided by the radius, which in this case the y is the square root of 3 and the radius is 2. Y is the square root of 3 and the radius is 2. So that means that the other values are 1, right? So the value or the angle that in which sine, in which is opposite that of the square root of 3, it will be a 60-degree angle. Same with this one, right? So we need to write the equation in general form. So I'm going to be writing the equations down here. Okay? So x over 2 equals 2. Now the first one is a 60. If you write it in standard form, this one is going to be a 60-degree in standard form, right? Because it starts from the x-axis to the terminal side. So that one is actually 60. And that angle is going to repeat every 360, every multiple of 360 afterwards. 360k means every multiple of 360. Okay? Now, let's find the other general solution. What is this angle going to be in standard position from here all the way to the terminal side? Since the reference angle is 60, then from the standard, from the initial side, which is the x-axis, all the way to the terminal side is 180 minus 60, which is 120 degrees, right? So that's the angle in standard position. And again, sine is going to repeat every multiple of 360, which is 360k. Okay? Then those are the solutions for x divided by 2. Question is, how do I find the solutions for x? Multiply both sides by the 2. Likewise in here, right? Multiply both sides by 2, so that way I can get the x by itself. So it's going to give us x is equal to 60 times 2 is 120 plus 360k times 2 is 720k, which is every multiple of 720. The other one is x equals to 120 times 2 is 240 degrees plus every multiple of 360k times 2, which is 720k. Okay? Now, we need to find all the solutions according to this between 0 degrees and 2 pi, which is 360 degrees only. Okay? Between 0 and 360. So what happens if you let k be equal to 0? We're going to start always with k equals to 0. So it's going to be 120 plus 720 times 0. That is going to be 120, right? That is that angle, 120 degrees. That is my first answer. Second, x is equal to 240 plus 720 times 0. That gives me 240 degrees. Are both of these angles between 0 and 360? Yes, right? Now let's go for k equals to 1, and you will see that this one is going to stop already, because if I substitute a 1 into the k, 720 times 1 is 720 plus 120 is 840, and that one is way over the 360. And the same thing is going to happen with this one. 240 plus 720 times 1 is 720 plus 240 is 960. So that one is way over my 360. So in this equation there are only two solutions, and the solutions is 120 degrees and 240 degrees. And you can check them by substituting them in the original equation, and you will see that it will make it true. These are my answers. If you have any questions, you can ask me in class. And the last question that I am going to do here in class with you is going to be this one. We're going to end up with this equation right here. Okay. So the last equation, this one basically we're going to use factoring. This is what it looks like to be. If you look at the problem, it looks like a quadratic equation. So you can factor it by grouping. Now if you want to make it easier for you, let's pretend that the cosine of x, let's give it a letter. Let's give it the letter A. So that way you understand this formula best. Because if you rewrite it, it's going to be more understandable. This is the same thing as saying 2. And since we substituted the cosine of x with the letter A, that means 2a squared. Plus cosine of x means plus a minus 1 equals to 0. If you factor this, remember the way I show you to factor, again, which it's my preferential way of doing it. Multiply the a times c, which is 2 times 1, that is 2. You can factor by grouping if you want, which is completely okay. Two numbers that multiply to 2, and when I subtract them, they give me a 1, is going to be 2 times 1. So I'm going to open two parentheses right here, and that is going to be a and a on each side, right? And then it's going to be, since it is a positive 1, it has to be a positive 2 and a negative 1. Then the a times c method tells you that you're going to divide both of them by a, which is a 2. Or if you can use your grouping, and you're still going to get the answer, and that gives you a plus 1 in one parenthesis. And since this one I cannot divide, I move the 2 in front of the a, so it's a 2a minus 1. And now you already have everything set up, the factors. So put back the a into cosine of x. So the a, remember, represents cosine of x. Cosine of x plus 1 times 2 cosine of x minus 1. Those are the factors for this. Okay? So then you set them each one equal to 0, right? That was the procedure. So cosine of x plus 1 equals to 0. And this one, 2 cosine of x minus 1 equals to 0. Solve for x, so I move the 1 over, so you get cosine of x equals to negative 1. And to get rid of the cosine, you do the cosine inverse of negative 1. Okay? So that means what? That you're finding an angle for which the cosine inverse equals to negative 1. Right here you're going to do the same thing. So you add the 1 to both sides, so you get 2 cosine of x equals to 1. And then divided by 2 on both sides, you get that cosine of x equals to 1/2. And to get rid of the cosine, you will do the cosine inverse of 1/2. And again, anytime you do the inverse, remember you're looking for an angle. So right here you're looking for an angle for which x divided by the radius will be negative 1 divided by 1. Now on the other one, you're looking for an angle for which the value of cosine is going to be 1/2. First of all, for this one, we need to determine cosine is negative on which quadrant. Cosine is negative in quadrant 2 and quadrant 3. Now, cosine is x divided by r, right? So it's going to be negative 1 divided by 1 in reality. So this is your negative 1 divided by 1, negative 1 divided by 1. So how is this possible that the value of x and the hypotenuse have the same length? Is it really possible? Get your if you look at it in the calculator, that value. Okay, if you do the cosine inverse, so let me check if it is in degrees. I want to have my answer in degrees right here. If I do the cosine inverse of negative 1, what does it give me as an answer? 180 degrees. Oh, these are quadrantal angles. That's why it is not possible. So these are actually quadrantal angles. Remember, if we go back, so on this one is not a triangle. So it's not going to work as a triangle because it is not possible. But if we go back to the unit circle, on the unit circle, like remembering that the cosine is represented by the x, right? On which angle is going to give me a value of x of -1. So the only angle would actually be this one right here, right? If my terminal side ends up here, that is an angle, like from here to here, that is an angle of 180 degrees, and right there the x is -1. So we're assuming that it is not a triangle, right? It is just one value, because you cannot have a triangle in which one leg and the hypotenuse is exactly the same. So right here, this one was talking about a quadrantal value, because whenever for the x value, to be -1, in this case, the radius is -1, and I mean the radius is 1 because the radius is a distance, right? If you look at the unit circle, the radius is 1 and the x is -1. So -1 divided by the radius, which is 1, gives you that value of -1. So that is going to be an angle of 180. So your theta right here is 180 degrees for this one. And after how many degrees does this value is going to repeat again? Every 360 degrees, right? Multiple of 360. So if I do a complete rotation of 360, we go back to the same angle. If I do another complete rotation of 360, we go back to the same angle, right? So that's what it's going to give us. Every rotation of 360, we go back to that. So on the other one, let's create a triangle for the other scenario. Now we want to find an angle for which cosine has a value of 1/2, and it is positive. So we need to determine, first of all, cosine is going to be positive in which quadrants? In quadrant 1 and in quadrant 4. So if we draw the triangle right here, we want to find the angle theta right here that will give me an adjacent value of 1, or if you put it as y over x, that gives me an x value of 1 and a radius of 2. That is cosine, right? X over r. So the x is 1 right here and the radius is 2. So the other one is the square root of 3, right? And if you look at the definitions, the opposite angle to the value of the square root of 3 is going to be a 60-degree angle of reference, right? So right there we have two solutions for that, right? There's two angles that will give me that solution. And the two angles will be, so the first one is just a 60-degree angle, but then it is going to repeat every multiple of 360 degrees. It repeats every multiple of 360 degrees. Likewise with the other solution that we get. This one, this angle right here, if you put it in standard position, what is that angle going to give us? From here, which is my initial side, all the way to here, which is my terminal side. If that angle of reference is 60, the total is 360 minus 60, so that's going to be 300 degrees, right? So my other solution will be 300 degrees plus every multiple of 360 degrees, which is 360 degrees K. Okay, those are the general solutions, but we want the solutions just between 0 degrees and 2 pi, which is 360 degrees. So we want those solutions between 0 and 360. Let's start out by saying that K is equal to 0. First solution, 180 plus 360 times 0 gives me 180 degrees. That is my first solution. Second, 60, I'm looking at this one now, 60 plus 360 times 0, it is going to be 60 degrees. That is my second solution. Next, 300 plus 360 times 0, that is going to be 300 degrees. And what happens if I let the k be equal to 1 in this one? What's going to happen is that my angles are going to go over 360, so that is not going to work because that's 360 plus 180, which is 540, and that is completely over, right? So it doesn't work anymore. This is 60 plus 360 times 1, so that's going to be 420, and that is over the 360 also. And this one is 300 plus 360, that is times 1, that is going to be 660, which is completely over. So this equation has only 3 solutions, and the 3 solutions are 60 degrees, 180 degrees, and 300 degrees. And you can check the solutions by substituting it into the original equation or by using the calculator to see if it is true. For example, if I put it in the calculator, like the whole equation, you can actually do it. You can say, I'm gonna put 2 times parentheses cosine of what is it? Cosine of 60 degrees. That is the first answer. Squared plus cosine of x, which is 60 degrees, minus 1 has to equal to 0, and that equals to 0. You see? Now we can check the next one, which is 180. So I'm just going to change the 60s to 180s. So that 60, I'm going to change it to a 180 and show you that this is also going to equal to 0, right? If I change this to a 180. So 180, and that equals to 0, right? And the last answer was 300, right? So if I change that angle to a 300 degree angle, then that is going to give us 0 as well. All of them equal to this value, which is 0. So all those are my solutions to this equation. So if you have any question, do not hesitate. Again, on Monday, go over all of this information that I provided you, and you can ask me on Monday any questions. Okay? Have a great weekend.